Hello friends, in previous video we have seen single pole system, transient response of single pole system, two pole system with left hand plane 0 effect and right hand plane 0 effect. Now in this video we will see single pole plus left hand plane 0 effect. So we are going to see these two things. So transfer function for this is 1, right? So we have one left hand plane 0 and another one is left hand plane pole. So with partial fraction method we will solve this. So let's see its step response. So for step response, so here for step response we will multiply this with 1 by s. So here 1 by s. Okay, so this is single pole's response. So this will 1 minus e minus omega pt into ut plus, and for this it will become like omega p upon omega z e minus omega p t ut. You can solve this and find out this thing. So this is your output time response. Output time response. Okay, now this is your single pole system response and effect of 0 is here. Now three cases arises here. Case 1 is case 1 omega p less than omega z. If suppose omega z is far away from origin, then it is single pole system response. Okay, because if omega z is very high, then this term is 0. Okay, so the response will be something like this. So say this is your input, then your response is like this. Your response is like this. Okay, now suppose omega z is, now this is omega p, omega z come close to omega p, but omega p is less than omega z, then how your response will change? It will be something like this. So sudden response here, this is omega p upon omega z less than 1. Now suppose let's see case 2. Case 2, omega p equals to omega z. So omega p upon omega z equals to 1, and response will be something like this. Or if I, yeah, so this is 1. So it is same as your input response, same as input response. Now let's consider case number case 3. Case 3, omega p greater than omega z. It means so this is your omega p, this is your omega z, more close to origin. So this was the case when omega p and omega 0 are same point. Now here what will happen? Here it will be settled like this. So this is omega p upon omega z. Omega p greater than omega p upon omega z greater than 1. Okay, so this is your timing response actually, and your input is something like this. Okay, so here point to note, you need to note left hand plane 0 speed up the system, so this is your say input, this is your step input. Okay, this is your step input, then your output will be like this three cases. One is this. Okay, so say this is 1, then another output is like this, and one output is like this. So this is case when omega p less than omega z. This is case omega p greater than omega z. This is case omega p equals to omega z. This is 1, this is 1, this is time axis. So this is our last case. We should know about this thing. So left hand plane 0 speed up our system. So this concept you should know how 0 is going to impact our system actually, and how two pole system is going to impact, and how single pole system is going to give transient response. Now another thing, we are going to see second order system, and how second order system, there are two poles in second order system, how it will give transient response. In upcoming videos we will see transient response of second order system, and yeah, we will also see Bode plot, and Bode plot for complex conjugate pole. So now which I haven't done so far, so just I would like to do here, or okay, I will do this in next video. Yeah, thank you.